Okay, so probability continues. Let me recall you about disjoint event. Two events are called disjoint if the intersection is empty. Right? So two events have not touching each other. So this one implies P of A and B. By the way, a lot of time I use notation. This is called this and. If you write latex, it's yeah. You are not responsible for this, but when I write, you are responsible for understanding it. Because I'm going to use notation a lot. I don't write letters because it take longer and take up space. So they mean the same thing. P of A and B for disjoint should be equal to 2. Maybe somebody from this side equal to. Do you know the answer? Or you know you don't want to say it. No, it's the or. It's the or, Muhammad. The one you answer is the or. Should be equal to? Yeah. No, that's the or. That's the or. This is the and. I just said it. 0, right? You didn't know intersection. Yeah, remember, and means something in common. Say, I like certain movies, right? Dan likes certain movies. If two of us like certain movie, that'll be a smaller, right? A smaller set, right? Has to be in something in common, so we will watch together, right? Right, Dan? All right, now the additional rule for disjoint. Additional rule for disjoint is P of A or B, and or again, I'm gonna use notation P of A union B. That's right here, mean or union. I mean union or union. That's a union notation. Again, you're not responsible for notation, but when I write, you're supposed to understand. You guys said it. Mohammed and Randy is what did you guys say? It's equal to what? P of A or B. I mean, I want both. So I want everybody in here and everybody in there. So P of A plus P of B, right? And this rule only apply for disjoint. Okay, only apply for disjoint. Let me highlight it. Usually on the exam, if I say I give you something and I ask you to prove that the event A and event B are disjoint, then you use this rule. If you prove that there's no intersection, they mean they disjoint. Right? So this one say you to prove that. In statistics, I rarely use the word prove, only in probability, because it's math. Probability is math. But if I later, as when we go to what's it called, inference, statistical inference, I'll never use prove, because we don't prove in statistics. We hope that it's right, but we don't prove. We estimate, right? To prove that A and B are disjoint. Do you guys remember what's another name for disjoint? Did I mention it? I don't remember. Mutually exclusive. Did I say it once? But it wasn't a lot, was it? Yeah, mutually exclusive. But I use the word disjoint because it's shorter. Okay, so those are recall. What about if they not disjoint? What about they not disjoint? Now let's think about there's P of A and B. There's no longer 0, right? Not 0 anymore. I don't know what it is, but it's no longer 0. So if they not disjoint, this one imply P of A and B again and is no longer 0. Something else. It could be independent, it could be dependent, it could be, no, definitely not complementary. Because there's more than more than two sets here. Now, how about the additional rule? Is it chain? Absolutely chain. Remember, well, the additional rule is, well, if I want P of A or B, I want everything of A and everything of B. So I gotta be careful. If because if it were two separate balls, then all I did is add up A and take A and B and plus add up together, right? But here they intertwine. So if I want P of A or B, let me highlight something here. I want this. P, that's P of A. That's P of A. Let me write it down here in blue. This is equal P of A plus, maybe I'll do yellow. So B, P of B right here. P of B. Can you guys see yellow? Make it dark yellow. That's P of B. But what happened when I do that? What happened with the in the intersection? I counted twice. Yeah, I counted twice. So I need to remove that double count. How do I do that? Well, I subtract P of, well, what is that middle thing called? What's that middle intersection? P of, that's where, that's A and B, right? That's A and B. So I'm going to subtract A and B. Why? Because I want to remove the double count. So this part right here, the reason you do this is you remove the double counting. The double count. Do you guys understand this part? Yeah. So when it, let me ask you something. Is P of A or B in this case, which is equal to P of A plus P of B minus P of A and B, is it less than or greater than P of A or B in this joint? What do you think? Which one is big? Maybe I'll make it in color so you understand what I'm talking about. Purple. I'll make this one in purple. Oh, how come it doesn't? There you go. So this is my purple P of A or B, which is from that, versus the red one from this joint, this one. So let me ask you, P of A or B versus P of A or B. So this one is from the disjoint. It's from the disjoint. Not disjoint. Which one is, what is the inequality face? Let me go back here. You know what, don't go ahead and put in the chat. Go ahead and put in the chat. I want to know. Yeah, in there, huh? Oh, can you, what is inequality? So this is, the red one is P of A or B from the disjoint. And the purple one is P of A or B from the not disjoint one. What's inequality would you put? This way or this way? I would say put the equal style as well. You have to be more specific, Rami. What's less is what's less. You can say red less than purple. You can say that, or red greater than purple. So your option is this way or this way. What's your option? Okay, I'm going to start. Once I start, your answer will be invalid. Okay, let me see. All right. Rami, did you read?
I agree.
Oh, okay, okay. Rosa, destroy less than that. Destroy. Fatima, red greater than purple. Rami, red is less than purple. Dan, you're not wrong, but you're not wrong, but it's not correct either. Not fully correct. Autumn, red greater than purple. Carly, destroy less than not destroy. Steph, red is greater than purple. Larissa, red than purple. Maggie, Mohammed, you mean the red greater than the purple? Is that what you meant? Ella, Fatima, Syed, Fatima, Lali, huh? Oh, that's okay. That's all right. That's all right. Jessica, Brandon, Dan. Good job, Dan. Tyler, Daniel, Max. Ella, change your mind.
Yeah, sorry, I put the wrong one.
Mohammed. Okay, thank you. Okay, people who say greater than, it is greater equal to. Why? Why people who say greater than, then tell me why you choose greater equal to. Who say? If you guys not volunteer, I'm gonna pick one from here. Hmm?
So with the things that overlap, you're taking them out.
Mhm.
Subtracting from both sides.
Mm-hmm.
So that-
Sort of. It is involving the overlapping, but maybe I need a little bit more clear. Anyone want to give it another shot? Say why? Yeah.
For the disjoint,
Mhm.
you're counting like both of the whole circle.
Good.
while for the not disjoint, you're only counting the part where the
Yeah. Solid. Yeah. Right. Because the double counting, you don't count it again, right? Very good. Yeah. It should be bigger. The disjoint should be bigger. Two whole ball. As versus to this not disjoint, it's not two whole ball. It's part of the ball. And then you'll only account for that one once. Yeah.
I kind of got lost for just a second, like previously. So it looks like a U. What's the difference between the one that's facing up and facing down?
Oh, right here. I wrote right here. You mean or. And then N mean the cap.
Okay.
Yeah. It's on the exam. Feel free to use letter. Okay. You're not responsible for notation, but when I write, because I'm saving space and it's faster for me, I use notation, which you should understand. Yeah. But try to remember that. Very good. So you gotta understand what happened. Here is the rule. I'm just rewrite it here informally in typing. That's all from the colorful one there. But there's a rule, right? This is the apply the rule for any two events, even the destroy. Why? The intersection and destroy will be what? Zero, right? So this guy will be what? Zero. So minus zero is nothing. That's how we don't write it. So this is the general rule for all the event, all types of event. Okay, let's try this one. We do this together. During the first week of 2019, the Pew Research Center is a very reputable organization. Track the types of English language YouTube videos posted. Let A be the event that the video posted involve games of some sort, including sport, and B be the event that the video posted involve hobbies and skills, including sport. Pew Research Center finds that probability A is equal to 30%, P of B is 13%, and P of A or B is 34%. I want to know, let me draw they want you to come up with the Venn diagrams that show all of these events. I'm going to show you how you do this. First, you draw a box. What the box represent? Yes, sample space. And then you have two events, so two oval. You want to do ball, you can do that. You red and blue here. So red will be event A, and blue will be event B. A and B. A and B. I'll highlight in yellow. Oops, too dark. I'll highlight again. A and B is this right here, right? The intersection, right? That's A and B. A and not B. A and not B, maybe purple. A and not B. By the way, A and not B, I can write it like this. A and mean the cap. Remember the upside down U. Not what's not B in notation? And last time we learned, not B is B what? B complement. B complement or B bar, right? B complement. So I can write like that, and you understand is A and not B. A and not B mean A, but I don't want to B. So A bar is here, but because this thing is including B, so I don't want that. So all I highlight is the part, the A, the A part without the intersection. A and not B. This part right here is A and B. B and not A. Tell me, where do I shade B and not A? B and not A. Where do I shade B and not A? The blue, yeah, the part of the blue. B and not A. So B and not A, like that. So right here, and you don't want to include that intersection because that's part of A. So, but I don't want A. So B intersection A complement. Last one, neither A nor B. Neither A nor B. Why is neither A nor B? Yeah, and it'll be outside the balls, right? Outside the two balls. So neither, I'll highlight in black. Oof, sorry. This will be A complement. Yeah, I think that one. A complement union B complement. Neither A nor B. Or and. I can use and. Done. I think it's and. If I'm wrong, I'll fix it. But I think it's an and. It's an and. Yeah. So right here. Right. Careful, don't want to cross the two oval. So A complement B complement. Okay. Can you do that on the exam? Maybe I'm thinking about it. But I hate it when I had to raise, because most of you probably don't use color. It's hard to see. We'll see. Find all four events. Find the probability of all four events and add the probability to your Venn diagram. Well, we're not gonna add, but we're gonna find the probability. So the first one is the and. I did in yellow. I want to know what's P of A and B. Well, I don't have that rule, but what do I have? What rule do I have that involve P of A and B? What rule do I have? See, it's wrong. How do I calculate P of A and B? How do I get rid of this think that subtitle thing here? Anyone know? It's annoying. Oh, line transcript. Oh, right here. Assign. Oh, okay. Thank you very much. Thank you. Someone say something earlier. How do I know? How do I find P of A and B? You know the formula that have A and B in it. Yeah, the additional, right? Very good. The additional. So recall. Additional rule. I tend to write things out, so later when you read, you remember. I have P of A or B equal to P of A plus P of B minus P of A and B. Well, I want A and B, so this P of A and B is equal to P of A plus P of B minus P of A or B. This is simple math. You should be able to do that. You plug it in, see what's P of A. The P of A is 0.3. P of B is 0.13. P of A or B is 0.34. What did you got? Like, .3 plus 0.13 minus 0.34. I got 0.09. So far, so good. Pretty simple. Okay, P of A and not B. purple. Okay, P of A and not B. This one, you're gonna eyeball it. How do I calculate P of A and not B? Should be easy. No, not one. I just want A and not B. I mean, I want this purple part. Anyone on this side? I just want this purple. Do I know the red ball? Yes, I do. 0.3, right? Do I know the yellow part? The intersection. We just did the yellow part. We just did, right? We just did. Right. So I want the purple, red minus yellow. Right. So it's gonna be P of A. The rest is P of A. Minus the yellow is the intersection of A and B. So P of A and B. P of A is 0.3. P of A and B is 0.09. 0.21. Okay, you guys do the green part and put it in the chat. P of B and not A. Oh, it's right there. That's the picture. Oh, okay. But I'm gonna scroll back up so people can see the picture. So that's where you're gonna calculate. Put it away. By the way, P of A and B is 0.09. Oh, sure. Sorry. Karim, is that your name? Yeah. Start showing the result. By the way, initially I wanted to use iClicker because it import the grade straight to my book, but it's cost money. I don't know why. It's free for some people, it's free for me. And all I did is using OU email, but it costs money for some people. I don't know why. I asked the lady and she said it costs money. For some people it's free. I don't know why. Too bad. Okay, so let's see. Oh, a lot of 0.04. Look like we got the right answer. So 0.04, Remy, Larissa, Steph have different answer. Rosa 0.04, Fatima, Autumn, Max, Kyle, Brendan, Tyler, Maggie, Holly, Ella, Kareem, Mohammed. Very good, thank you, Mohammed. Fatima said, it looked like it. I don't know what it is, but it looked like it. Okay, so I want the green part. So you take the blue part, which is P of B, right? Minus P of A and B again. This is 0.13. 0.13 for the B. Minus 0.09. 0.04. All right, for those, give yourself a bonus check mark. And again, remember to put them on them, okay? Because that will be your point at the end of the semester. It's up to 15 points. That's a lot. Your exam is 100 points. That's 15 points is a lot. Or your final is 200. But still, 15 points is a lot. Last one, neither P of neither A nor B. A complement and B complement. Let's see, should not be so big. Okay, I want that part, the black part. I want this black shade area right here. Go ahead and put in the chat. All right, let me check. Wow, a lot of 0.66. Mohammed. Okay, so Max 0.48, Autumn 0.66, Muhammad 0.57. Is the three first answer is very different. 0.66, Carly, Fatima, Rami, Larissa, Ella, Tyler, Rosa, Brendan, May, Kareem, Dan. Wonder how did it go? Okay. Yeah, it looked like it can be 0.66. So I want this part. So that means I have to remove the two bars things, right? So is that what those for? What are those? So it's gonna be 1 minus the two ovals. So that's P of A or B, right? That's P of A or B. P of A or B. So 1 minus 0.34, 0.66. So if you most of you understand what you're doing, so that's good. Others maybe you make mistakes somewhere, but you should understand when you look at the Venn diagram. Okay? Let's finish the independent and then we'll take a break. Independent and multiplication rule. Okay, so far we know something about disjoint events, and that's all we know. Other than that, we should know that they're not disjoint, right? Another possibility is your two events can be independent, it can be dependent, or it can be complementary. But we're not going to talk about complementary, so you don't have to worry about that. But but we're going to talk about independence. Independence. We're not going to do dependence either. So just dependent. Two events A and B are said to be independent if knowing one will occur or has occurred does not change the probability that other occurred. Let me give you an example. A couple have a kid. The probability that a couple having a second baby has nothing to do with the probability they have the first baby is girl or boy, right? The second one, First one, boy, girl, 50-50. Second one, still 50-50, right? Does not change, probably did not change. Same thing with flipping coin. Assume that your coin is fair. I'm saying that the coin does not, being altered physically, that you have like 60% for head and 40% for tail, 50% for head, 50% for tail. So that's independent, right? The probability you flip in the first time is head is independent to the second flip. Right? Second flip will be head or tail, same. So probability does not change. As the result of this independent definition, we should show that the multiplication rule for independent event reduced to P of A and B is equal to P of A times P of B. And it makes sense. Think about it. When you say or, you want everything. So your probability should be a bigger number. Yeah. But when you want and, you want something in common. That's reduced, right? That's reduced. Say I like certain movies, somebody else likes certain movies. If you take a intersection of those movies, it'll be smaller, right, than before. So why multiplication? Because we want a smaller probability. If you take a fraction that between 0 and 1, and you multiply with another fraction which is between 0 and 1, you get a smaller or bigger one. Say 0.1 times 0.1 would be what? 0.01, smaller. So that's why it's multiplication. And this only apply for independent event. Do not assume that your event is independent. If you see two balls kind of intertwine each other, it's not disjoint, it must be independent. No, it could be dependent. You have to prove that it is independent or not. So this one right here, this is a very important formula. It's only work if your A and B are independent events. Why so dark? It's only work. So this one only work if A and B are independent events. On the exam, if I don't say independent, do not use this one. Okay. All right, so here the heads up for the next section is called conditional probability. There's another formula that you can show A and B are independent is P of B given. The vertical means given, not divided. Given probability A equal given later. Don't worry about it now, but later. Okay. But again, if I ask you prove that A and B is independent or not, you're gonna use one of these. I like the first one. This one okay. It's not hard either. So I like the first one because it's easy to understand. Okay, so let's do this one. What is the probability of rolling a 6 and multiple of 2 on a 6 side of dice? All right. All right. So you flip, you roll dice first time. What is the probability of rolling a 6? 1 out of 6, right? So P of rolling a 6 is 1 out of 6. What about P of multiple of 2? What multiple of 2 mean? What multiple of 2 mean? You have 1, 2, 3, 4, 5, and 6 sided dice. Okay. What are the numbers that is multiple of 2? What are those numbers is multiple of 2? Oh, come on. Huh? Yeah, 2, 4, and 6. Thank you, Fatima. 2, 4, 6. So how many desired outcome are there? 3, right? 3 out of what? Yeah, 3 out of 6, right? 3 out of 6, which is 1/2. So the probability you rolling a multiple of 2 will be 50%. Pretty good. Assume nothing happened. The first row and the second row is independent. Yeah. I assume nothing gonna happen, right? I don't think my hand have memory that I roll a 6. I want to roll a 6 again. My hand will do that. No, right? There's no memory. So So it's independent because two event independent. Independence. Independent, you can use a rule. And now I want to know what the probability of rolling a 6 and a multiple of 2. So this implies I can use P of 6 and a multiple of 2 is equal to, John, I will first, maybe I'll go down here. Independent is equal to what? P of rolling a 6 times P of rolling a multiple of 2, right? Multiple of 2, which is 1/6 times 1/2, so 1/12. Is that okay with this process? Probability is interesting. I wish I know more. I'm not gonna lie, I don't know much about it. My entire life doing statistics is I analyze data, company data, tax, stock, mostly stock. But probability, I'm rusty. I know the rule. It's just when it gets complicated, and I don't know. So this is nothing. When you guys take a discrete course in OU, you know it gets more complicated. It has stages. If you know probability, good for you. Chance that you're gonna make more money than I do. All right. Common names. The U.S. Census Bureau say that 10 most common names in the United States are in order are Smith, Johnson, Williams, Brown, Jones, Miller, Davis, and Garcia, Rodriguez. How do I say that? Rodriguez. 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 Thank you. And Wilson. Wilson. Remember the name of the movie? Wilson. These men account for 9.6% of the U.S. residents. Out of curiosity, you look at the authors of a textbook of your current courses. There are 9 authors in all. Would you be surprised if none of the names of these authors was among the 10 most common names? Well, we'll find out. We'll find out. So I want to know. So the probability of someone have one of those common names is 0.096. Yeah. Let me write down. P of someone would have a common name. The probability of someone will have a common name is equal 0.096 divided 9.6 divided by 100. So what is the complement? What is the complement? P of someone doesn't have a common name above. Is what? 1 minus, right? 1 minus 0.096. Right? Either your name is one of these or you're not one of those, right? Complementary rule. What is that? 0. Oh, not 0.4. What is that? 96 or 80, 90, oh, where am I? For 0.904. Yeah, 0.904. Thank you. 0.904. Wow, that's a big one. Roughly 90%, right? Okay, so you have 9 authors in your textbook. Is the event that one of the event that author 1 and author 2 have the same name or same common name or not same common name is independent or not independent? to be independent, right? One author has nothing to do with the other author. The mother is different. They pick out different names. I don't think they contact each other, right? And say, let's pick the name together. So they're independent. So that means P of P of author one. So because it's independent, maybe best to write it here. I'm trying to figure out a way to state my presentation. It's independent. Independent event. This imply probability of some author one, does not have a common name. And time probability of author two, time blah blah blah, all the way to what, author 9, right? How many author are there? 9 of them, right? So 9 authors. So in terms of math, in terms of number, by the way, this could be complement, should be complement, right? We're doing complement. Not having that name. Not having that. Okay, so what is the probability of someone not having a common name will be what? 0.904 times 0.904 times all the way 0.904 to 9 of them, 9 times. Nine times. Well, that's the same thing as 0.904 to the 9 power, yeah. Which is, what do you got? Mike, I don't, so can someone tell me what the probability? .403. Thank you, Dan. 0.403. So roughly 40%. Does someone not gonna have a common name? I'm sorry, the probability if someone does not have one of those common names above is 40%. That's pretty high, right? So you won't be surprised. So roughly like 40%. I keep touching the side. 40%. So your conclusion, you weren't surprised. You wouldn't be surprised. Because of this. So that's the answer. I wanna, let's do this one more and then we'll take a break, I promise. Shopping online. Nowadays, a lot of people shopping online. I do too. Especially the Amazon 2-day shipping thing. All right, below our result for the a population of 1,000 customers that shop online for a particular website during the past holiday season. Recorded was whether or not they satisfied with the experience or whether or not they received the products on time. So satisfied on the horizontal, not satisfied on time, not on time. But what does it remind you of this table? We just finished it 2 lectures ago. What does this table remind you of? Something for categorical. We did 2 lectures ago. I forgot what chapter. Chapter 6? Yeah, chapter 6. Two-way table. Two-way table. Are being satisfied with experience and receiving the product on time specifically independent? Well, I don't know. We're gonna check it out, right? So let me remind you. How do I prove something that independent? What do you use? What I say? What do we use? Remember those? Yes, multiplication rule, right? I highlight something here, right here, right here. You either use this one or this one. But right now you don't know how to do this one yet, so we're gonna use that one. So P of A and B is supposed to be equal to P of A times P of B. So mathematically, if you can prove that the left-hand side has the same result as the right-hand side, then they are independent. Not that they're not independent. Okay, so let's find out what's P of A and B. P of A and B equal to P of A and B. By the way, what's A and B here? I'm gonna assume P of A is satisfy with experience, satisfy. And B will be the receive on time. I'm just gonna say on time. I don't have enough space. Okay, on your table, let's see. Let's highlight some stuff. Satisfy. Somebody satisfy is right there. That's satisfy, right? On time. So what is intersection? Intersection is 800. Yeah. So that's 800. But because you want probability, you don't want to put 800. 800 is the count. Then divided by what? 1,000. So that's 0.8. P of I want P of A and then P of B separately. So I want a P of satisfied. Satisfied is total is 820 and divided by 1,000. So that's a 0, not a 6. 0.82. Or what about P of receive on time? You tell me, what should I put here? What the portion here? Someone on time. Okay, thank you. 880 divided by 1,000. 0.88. Okay, so your left hand side is this one. 0.8. Let's see the right hand side. What I'm gonna do, I'm gonna take P of satisfied times P of on time, okay, which is equal to 0.82 times 0.88. 0.82 times 0.88. 0.7216. Are they independent? No, right? 0.8 is not equal to 0.7216. So your conclusion is the whole thing is not independent. You have more space, you can write out nicely. I don't have a lot of space. I'm just saying not independent. Well, on the exams, just write out nicely, okay? Say the being satisfied with experience and receiving the product on time is not an independent event. Okay, let's take a break. When you submit your quiz, I should know who's. Let's take a break. All right, continue with conditional probability. So we have additional, we have multiplication rule, and now we have conditional probability, conditional rule. Given again, P of A's are two events. Now, what if I give a condition, say something happened for event A, how does it affect event B next? Right, so that is conditional probability. You've been given a prior condition. So P of A given B, that vertical line in given is not division. It's not division. P of A given B is equal to P of A and B divided by P of B. So here's a Venn diagram. P of A and B is this purple part. Right? Here's P of, should be that, yeah. Let me fix it. Let me fix this. Let me fix this. I'm gonna say I copied this the picture from the textbook, so my way of explaining it, the type is slightly different. So I'm gonna call this is B. Oh, come on. This is, so that's B, and this one A. So this is P of B. Okay, let's change it a little bit. So P of B, so P of A given B is the proportion of the N part and the P of B. You cannot see here because the proportion is two. Okay. So I will never ask you to represent P of A given B on the different diagram. If you do, that's the best you can do right here. That's it. Right. But physically, you cannot see it. All right. All right. So let's do this one. Back to the shopping online problem. Now, my question is, what is the probability of randomly selected customer who is? Let me change it to who was satisfied, so that I don't have to find who was not satisfied. Let me change that. Who were satisfied? Right? Given that the person received the product on time. So which one is A? Which one is B? Let me write down here for you. P of A given B equal P of A and B divided by P of B. In this problem, what is my A? What is my B? What is my A and what's my B? Mohammed, you want to give it a shot? You can speak up. Everybody can hear you. I'm making nervous.
Okay, give me a second here.
Oh, sorry. You don't have to. You don't want to. Anyone else want to give it a try? What is P of A? What is P of B in this context? Yeah, go ahead. Say it again. Satisfy is. Oh no, just one at a time. So satisfy will be A, right? And then receive it on time will be. That's it. That's all you have to do. Yeah. Very good. Yeah. Thank you. What's your name again? Medicine. Thank you, Medicine. So here, I want to know what's P of satisfy, right? Satisfy. Oops. Yeah. Satisfy. Given. Receive on time. On the exam, usually when you hear the word given, you know that you have to do the conditional probability. Sometimes they don't use the word given. Sometimes they word it differently, but you should be able to tell. But I'll make it easy. I'll just say given too, so you know what to use. I'll say given. You know, use conditional probability. Okay, so according to the formula, what should I put on the top? What should I put on the top? P of A and B. So satisfy and on time, right? Satisfy and on time divided by P of B, which is P of on time. I know that I say that the vertical, it does not need division, but to make it easier for you to remember this, just gonna give you the denominator. P of on time. Okay, so P of satisfy and on time, I think we did it before. We don't have to do it again. Right here, P of satisfy and on time is 0.8. Right there, right? So 0.8. If you haven't done it, you have to do it yourself. 0.8. P of on time. I think we also did it here also. That's why I changed to P of on time, which is 0.88, right? 0.88. 0.88. 0.8 divided by 0.88. 0.9091. So roughly 91%, which is makes sense, right? If you satisfy when you receive your things on time. So 90% of people who satisfy if they receive their purchase on time. Again, your probability should be between 0 and 1. If you have some number like bigger than 1, something wrong. Do you have any question about this problem? On the exam, whenever you say given, use use this formula. Okay, all right, so let me go back to the formula. So that's the formula. And if the same thing is, remember the condition, additional probability, you gotta move things around. Same thing here. If I multiply both sides by P of A, don't write this down. If I multiply both sides by P of A, this is the equation, I'm allowed to do it. Or P of, I'm sorry, P of B over 1, P of B over 1. The right hand side cancel, yes? Yeah. So this imply what? P of A and B is equal to P of B times P of, P of A given B. Just move things around. Right? Sometimes, why do we do this? Because A and B, remember what I said, it's not always independent. Independent, you can do what? P of A times P of B. But what if they're not independent? Then you use this rule. Maybe I say something. Let me say something. It's useful. A and B are not independent. So I asked you to find P of A and B, they're not independent, you kind of stuck, so you can do this. If you have the P of A given B. All right, so which is this line right here? Same thing. This line is called general multiplication rule. Let me prove to you, I'll prove it down here. Let me recap. Show that A and B are independent events we use. Someone tell me what the first rule. If I ask you to show A and B are independent, what do you use? The two of them. Go ahead.
The two equations that we had.
P of A and B. If A and B are independent, you can split it apart, right? And then you multiply them together. So P of A times P of B. And the other one is P of A given B is equal to P of A. It's number 2. Now, is this notation wise? I keep doing that. Let me do this in blue. For this one, I can change it. If I want to change a letter, it's the same thing. If I change it into this, if I change it into, you don't have to write this down. P of B given A is equal to P of B. Okay, it's just a placeholder, nothing more. If A comes first, then come out P of A. If B comes first, come out P of B. Right? So P of B and A is what you want. But it's the same thing. It's don't matter, whichever you want to use. I'm gonna erase this because it's the same thing. Okay, let me prove it to you. Why is that P of A given B is equal to P of A when A and B are independent? We're gonna prove this, and then we're done. Not done, but we're done for the day. Prove this. Okay, recall. Maybe recall the general rule for conditional probability. Do you guys remember? Anyone remember without looking at it? P of A given B is, remember I say the proportion, right? The fraction of P of what? P of A and B divided by P of B. At the end, don't write this down. At the end, I want it to be just P of A. I want it to come from here to here. All right, because A and B are independent, then what happened? Well, the bottom is stay the same. Nothing I can do about P of B, but the top, because P of A are independent, what can you do? No, the top. Yes, yes, right? The red rule right there. And then your reason being A, B are being independent. And then you cancel. Yes. Oh. Cancel, cancel. And you got P of A. Right, which is- Yeah. See, so and all rules are general. It's because it's special case. It's kind of like disjoint. Remember the disjoint, the intersection is 0. You just kind of write it. Same thing here. It's just special because ABs are independent. All right, let's stop here because my iPad have like 2%. And I'm gonna start on the quiz. Roman, you can go ahead and take the quiz online, okay? But next time I don't want it to happen again. So it's kind of my fault to typo in the syllabus.
It's my bad, but one second, let me type in the chat.
Go ahead and check it. But I need to see your station, both of you. Mohammed, because he's sick.
Sorry, what'd you say?
By the way, can you guys turn around, just like you did last time?
I have my phone going as well on a different Zoom that has my screen.
No. Turn off your Zoom. I want you to turn off the Zoom before you start your quiz. But Mohammed and Roman, you have to show me your thing.
So do you wanna like screen share, or do you want me to
I can
just show
show
you?
you
what
my
it is?
No. I
screen
just want
from the
to
other-
see your face and your station. That's all.
Okay.
And so everybody else, please log out in your Zoom so I can see these 2 people.
Wait, did you add the quiz to Moodle?
Forty-five, 40, 45. Okay, if you refresh your Moodle, you should be able to see. Oh, my bad, hang on. I gotta show first. There you go. Thank you. So, Roman, you don't have to do that, Roman. Thank you very much.
Set it down.
No, Dan, I don't want you to be on Zoom. Everybody log out of Zoom so I can see the 2 people.
Saviors.